Cool, so now let's move on to part C. And in part C, we're going to have the exact same problem as we did in part B, except we're going to do it recursively. So remember that in recursion, we can't do exactly what we did in iteration and have some counter variable. And that's because the counter variable is always going to get reset every time we have some recursive call. So when we do count letters recursively, remember that we have to have a base case and a recursive step. And so now we have to kind of think of how we're going to be simplifying the problem as we recurse. So what I'm thinking is we can do something really similar to what we did in iteration and compare this character C against one character in the string S, and then make the string smaller because I've compared it against that letter, so I want to move on to a smaller string. So if I keep making my string smaller and smaller and smaller, I know my base case I'm going to be hitting is if S becomes this empty string, right? Because I've cut out all the other letters and S is just now nothing. So if it becomes this empty string, then I probably want to return something that we can probably determine later after we do our recursive call. So now moving on to recursive step. In my recursion, like I've already said, we need to keep track of how many things we've matched with, right? Because we don't have some counter variables, so we have to do this counting inside the recursive step. So inside the recursive step, I'm going to probably have to call match and match C with one character in S. So to get one character in S, I'm just going to grab the 0th index, just the very first character. Cool. So now after I've grabbed the first character, I can cut that character out and pass on a smaller string to through my recursion. So I'm going to call another count letters. And I know C is going to stay the same, and now I had to make S smaller and cut out the 0th index, right? So to do that, I'm just going to do one like this. So strings are also stored as lists basically. So whatever you want to do to a list, you can also do to a string. So this slices the string takes everything after the 0th index. Cool. So now we finished our recursive step, and now we can go back and fill in our base case. So we know that this match is gonna be giving us a 1 every time we get a match. But when we're at an empty string, we probably don't want to say that there's been another match, right? So we probably just want to give it a 0 and not change how many matches we've gotten. So let's just give a quick example of what count letters is actually doing. I'm going to abbreviate it as a CL and pass in some string A, B, and and I'll pass in C as B. So, and I know my first call to CL, I'm not going to hit my base case because AB is not an empty string. I'm going to call match on the 0th, or on B, and the 0th index of S, which is A, added together with another recursive call to CL. I'm going to cut off the A, so I'm going to just have B left, and have another B. Cool, so now this match, I know is going to return me 0, and now I'm going to continue recursing. So the next CL is also going to give me a match. And this time I'm going to get a B, and I'm going to add it together with one more recursive call to CL, where I cut out the B, and C is still the same. Cool. So this will give me 1, right? Because I know B matches with B. And this CL is going to stop recursing because I've hit my base case, right? I've hit the empty string, and so I know I'm going to return 0. So now I'm going to start going back up the recursive call stack, right? So I know that this CL here is going to return me 1 plus 0, so it's going to give me 1. So all of this goes away, and I just have this 1 now. So now that this CL has given me 1, I have a 0 here, I can evaluate this expression, right? And I know this expression evaluates to 1 plus 0, or 1, right? So I know that this CL returns a 1, and all of this stuff goes away too. And so now I'm back at the top of my recursive call stack, and I have 1, right? And that makes sense because there is only one B in the string AB.